Hello. Okay, good. My audio is on. Hello. Welcome to my session. Today we're going to be talking about developing cross-platform mobile apps using React Native and AWS AppSync. And we're also going to be using AWS Amplify a little bit. We've done a lot of announcements around Amplify over the last 24 hours, I guess. So we'll touch on that a little. We've also had a few announcements around AppSync, I think over the last week. So we'll also talk about those a little. But to introduce myself, my name is Nader Dabbit. I'm a developer advocate for AWS Mobile. I've been with AWS Mobile for around a year. Before that, I did React Native training for a company that I own and still manage called React Native Training. We did training over the last 2 to 3 years, 2.5 years, I guess. We did worked with companies like Microsoft. We worked with Amazon. We worked with American Express. Worked with a bunch of enterprise companies that were exploring React Native at the time. Some of them picked it up. Some of them didn't, depending on their situation. But we've been doing this React Native training, kind of exploring and getting an idea of what companies are looking for. It's really kind of eye-opening to see some of the reasons why people are choosing React Native and why people are not choosing React Native. But today we're going to be going over kind of a few different things. We're going to be talking about just a quick intro to React Native. We're going to do an intro to AWS Amplify and AWS AppSync as well. We'll look at how to create and configure an AWS Amplify project and create a new React Native project. We'll look at how to create and configure services with the AWS Amplify CLI. That's what we're going to be using in our demo to kind of create the AppSync service. We'll look at another way, which is directly through the AWS console as well. And we'll talk a little bit about GraphQL and AWS AppSync, about schemas, resolvers, and kind of like some of the stuff that goes on under the hood and kind of what you might need to know if you're going to be building anything with AWS AppSync. And then we'll look at how to connect a AWS AppSync API to a React Native project. And a lot of the stuff we're going to be looking at in the last part, connecting to a React Native project, is actually something you can kind of take and use in other environments as well. We support not only React Native first class, but also web, iOS, native Android, and native iOS. And we also have framework support for a few different front-end libraries, mainly around JavaScript. So we'll look at those as well. So to start things off, we'll go over a little bit about React Native. This isn't really intended to be like a deep dive, just an overview for whoever may have not already tried React Native out. Who here has not used React Native? Okay, cool. So a good mix. So a quick intro, React Native was open sourced by Facebook about 3.5 years ago in March of 2015. It was originally built as a mobile application framework, cross-platform, but what we've seen over the last couple of years is it's now being deployed across other platforms that aren't actually mobile. So for instance, there's React Native Web, React Native Desktop, Tizen. You can do stuff with the Apple Watch. You can deploy across a bunch of different platforms. Some of them are supported pretty well. Some of them are a little janky. Some of them don't have as good support as some of the main ones, but you do have the opportunity to kind of use React Native and deploy in other areas. Whereas most of the original cross-platform frameworks that came out prior to React Native were built as write once and run anywhere, React Native kind of was built a little differently, and the idea was always to learn once and write anywhere. That being said, you can use a lot of your code across other platforms. In fact, you can use, from what I've seen, around 80 to 95% code reuse in most real-world projects. So even though it's kind of not built as write once, run anywhere, you can kind of get there to an extent. And one of the interesting things about React Native is it's currently undergoing a big re-architecture, and we're seeing a lot of focus by the Facebook team on the React Native project, whereas maybe over the last year or so, it fell to the wayside a little bit, in my opinion. There wasn't a lot of action going on in the GitHub repos. Issues were not being handled that well by the team. They've brought on a couple of new people over the last 6 months to kind of re-energize, and they're really re-architecting it to kind of address some of the issues that people had, mainly around brownfield application development. There was a big article about Airbnb. They were one of the thought leaders in the React Native community for a while. They were using React Native in around 10% of their native app. They moved away from React Native and wrote an article and kind of laid out the reasons why. So it kind of got a little negative press there, but we're really seeing a lot of use, from what I can tell, and a lot of enterprise companies are still picking it up. So React Native has this idea of UI primitives to build your UI. You have primitives that are kind of similar to things that you might use in the web. So if you've ever used a div, you can kind of conceptually map that to a view. If you've ever used an IMG tag, you have image, so on and so forth. The main difference, I guess, between the web and React Native when you're using these primitives is the scope is available on the web. You don't really have to import a div. The div is just there. With React Native, you do have to import these primitives. So if you need to use a view, if you need a scroll view, whatever you need, it has to be imported into the component before you can actually use it. And your React Native apps are composed of different components, and these components are built using JSX. This is an example of JSX, and it's essentially a syntax extension to JavaScript that allows you to kind of build your UI, and it comes with all of the features that JavaScript has. So you can use JavaScript within your JSX. And there's two different ways to build these components, either using functions or classes. Here we have a function that returns some text. Here we have the exact same component written using a class. The main difference is in a class component, you have access to the component lifecycle. The lifecycle allows you to hook into different events, also create class methods, and create local state. So what we're seeing is normally if you're using a component that only needs to render some UI and you can pass data to it, you end up using a function. If you need to control your state, if you need any of these lifecycle methods, you'll write using a class. And recently they've come out with something called React Hooks, and that is a new specification in the React framework that'll be in React Native maybe about when React gets to 17. I'm not sure when it'll come to React Native. But then it'll maybe do away with even the need to use classes, because with these hooks, you're able to handle application state within just a regular function. But anyway, so you would create a component, and when you're ready to use the component, you just import the component, and then you use it similar to the way you would use any other of those primitives. So here we just have a my component that we created earlier. We import that, and then we just render that out as JSX. There's also platform APIs. So one of the main reasons people use React Native is to have access to these platform APIs. So you can access native iOS and native Android APIs directly. This is kind of how that might look. You just import it from React Native. Anything that's available in the framework, you can import directly. You can also install third-party libraries or expose your own native methods. And then once it's imported into the scope of the file, then you can just use it. For instance, here we have a listener that listens for the connection change and tells you whether the user is on Wi-Fi or what type of connection they're on. There are two main ways to create React Native apps. If you look at the documentation, it's kind of hard to tell what is their recommended way. If you look, their main recommended way is actually using something called Create React Native App. And then there's another tab next to it that is the CLI, which is what I'm kind of showing off here. You can use either. They both have their own benefits and trade-offs. What I've seen, though, in most enterprise companies is they use the React Native CLI, because with the React Native CLI, you're able to access native code. You're able to change the native code. When you use Create React Native App, you're using an abstraction that's on top of React Native that does not allow you to change any of your native code. So if you use the Create React Native App CLI, not the React Native CLI, you are a little bit stuck there, and you can actually eject out of it, but then you're kind of maybe on a little bit later of a version of React Native. So I would recommend looking at both, but I typically use the React Native CLI to create apps, and that's what I'm going to be using for the demo. And the demo that we're going to be going over is kind of creating a React Native app, or actually using a React Native app that I just created before we started, and then adding Amplify, adding UI, and hitting the AppSync service and adding an AppSync service. So the way that we're going to be using AWS AppSync, and kind of the recommended way, I would say, especially since we recently added a new feature to AWS Amplify for multi-environment support, it allows for testing, it allows you to create copies of your environment, break things, and not have it affect your main environment, is the AWS Amplify CLI. And AWS Amplify comes with more than just a CLI. It's kind of a bunch of different things at this point. We just added something called the Amplify console, and the Amplify console allows for continuous deployment. It's basically a hosting service right now for Amplify applications. With the console, we're going to be adding more stuff probably in the future, but check it out. It's actually pretty interesting. The CLI is what we're going to be using to spin up new cloud projects. So the CLI allows you to create AWS services without needing to go to the dashboard, essentially. And then there's an Amplify client library, and the Amplify client library just then allows you to connect to the services that you're creating through the CLI. And then there's like a tool chain, and the tool chain is just a bunch of different features that are part of the CLI that do things like code generation. So when we create our GraphQL API in just a moment, if you've ever worked with GraphQL, you know that you have to create a lot of client-side code for queries, mutations, and subscriptions. The tool chain, the CLI, will basically create all of that for us. So the main thing that you would use the CLI for is to create, configure, update, and delete AWS services. Now you can also check out different environments. So yesterday we added the environment support. It's still in beta, but essentially you create a new Amplify application, you add an API, you add authentication, whatever, you push it up, everything's going good, you're in your main environment. Now you maybe have a new developer come on the team, or maybe you want to try something crazy out, but you don't want to screw up your existing project. You can now initialize a new environment in your existing environment, or not really in it, it's going to actually make a copy of your existing environment. There you can do testing, you can play around with stuff. Once you get to the point where you like the new feature that you're working on, you then check out your original environment, and you have access to merge all of the changes that you made, and it will not affect any of your existing environment that you're in. It'll just update with whatever new features that were not there when you created the new environment. So it's really, really powerful, and we're seeing a lot of good response on the multi-env feature. But when you want to create services, like what services can you create? AWS has so many services, right? But with Amplify, we kind of support a subset of what's available in the main console. We do have access for database support. Right now, you can spin up DynamoDB. You can spin up Elasticsearch using the CLI. We have an API category that supports 3 different types of APIs. One of them is GraphQL. 2 of them are REST. The 2 REST APIs that we support are, one is just a Lambda function with API gateway, and we scaffold out an Express app with different routes. The other API that we support is a CRUD API that would work with DynamoDB and a Lambda function. And we also scaffold out all of the code for all of your typical CRUD operations, create, update, delete, all of that stuff for you. Lambda, AWS Lambda, you can initialize Lambda functions, invoke them locally, push them up, make changes, push them up. Authentication is one of the most used features, along with S3 for storage. Authentication allows you to create services using Amazon Cognito. You can use user pools and identity pools. Analytics, hosting, and interactions. So analytics is done using Amazon Pinpoint. Hosting is done using a combination of S3 and CloudFront. And interactions are just interactions with Lex. I think it's Lex is a chatbot. So how do you use the CLI? You install it, npm install -g. You configure it. You need to associate an IAM user with your current environment. To do that, you run amplify configure. It will either take you to the to the AWS console where you can create a new user, or you can just use an existing user that you have the credentials for. Or if you already have some credentials locally on your machine in your AWS profile, you can also recognize those as well. Once you've installed and configured the Amplify CLI, you now have this Amplify variable available at any time. You can just run it by running Amplify. It will give you a list of commands to add a new service. You run amplify add with the name of the service. When you're ready to push the local changes that you've done using the amplify add commands or amplify configure commands, you run amplify push. This takes the local configuration that you have and then actually creates the resources in your account. The resources are not created until you run the push command. And then if you'd like to configure an existing service, you can just run amplify configure, the name of the service, and it gives you a list of options that you can configure. So this basically allows you to move your workflow down into your local machine. It's really powerful for front-end developers. The client library allows you to then connect to the services that you just created. So we created this API. How can we actually use it from our front-end application? You use it using the Amplify client library. We have a couple of different framework supports. First-class support for Vue, React, React Native, Angular, and Ionic. But if you're using JavaScript, we also have all of the classes that are just exposed directly, and that's kind of the way that most people are doing some of the more sophisticated stuff with Amplify. You're just importing the auth class and then calling signup, for example. You're importing the storage and interacting directly with the storage class. But to kind of get up and running quickly, we're going to actually be demoing the React Native framework support, showing how to kind of do that, to kind of get up and running really quickly with a login UI. Some of the features that the Amplify client supports are some of the same ones that, of course, are supported on the CLI because you want to be able to create and then connect to these services. But we also support things like push notifications and internationalization. And internationalization is more of just a client thing. It has nothing to do with AWS. So we have also VR and AR support. You can't create a VR or AR scene using the CLI, but you can go to Amazon Sumerian, create your scene, configure it, and then have control over it using Amplify, embed the scene, restrict access, and those sort of things, re-render your scene. So that's pretty cool. I have a blog post on creating Sumerian scenes and using them with AR and VR, if you'd like to check it out under my blog. So to kind of use the Amplify libraries in your application, you just need to install them like you would any NPM module. So here we have kind of what that would look like, npm install AWS Amplify, the core library, and then you would need to install AWS Amplify dash the framework that you're looking to support. So dash Vue, dash React Native, dash React, dash whatever. And then you're ready to go. Once you've installed your dependencies and you have your new Amplify project created locally, you can then start using the project right away. And you would configure the project at a root level of your application. If you're using React, it would be something like index.js. And React Native, it's going to also, I believe, be index.js. But you import the Amplify library from AWS Amplify. You have an AWS exports file that's created for you by the CLI and also configured for you by the CLI with any changes. You import those two files, or those two components, and then you call amplify.configure, passing in the config at the root level, and you do that once, and kind of everything's ready to go. Then you can start importing classes and stuff from Amplify. So, for instance, we wanted to use auth. We can import auth from AWS Amplify. Then we can start calling methods on auth, sign in, sign up, forgot password, so on and so forth. There are over 30 different class methods on auth alone. Not counting all of the other different classes that we support. So you can pretty much handle everything with these components for an entire authentication flow. Time-based one-time passwords, reset passwords, all that stuff is pretty easy to do. To use the framework support, you just do the same thing as we did here, but instead of importing from Amplify, you import from Amplify-your framework. This is a higher order component that we're going to look at in just a moment that scaffolds out an entire authentication flow. And with Authenticator, you can use it in either React or React Native, I believe also in Angular as well. And it gives you sign up, sign in, forgot password, all that stuff. And this is kind of what that would look like in the React Native app that we're going to look at in just a moment. So like literally 2 lines of code gives you all of that functionality as long as you've enabled auth. So now the console, it's something that was, again, just released about 24 hours ago. So it's a continuous delivery and hosting service for mobile and web applications, and really for serverless applications. So it's a Git-based system. So whenever you have multiple developers, whenever you merge into master, it kind of kicks off a rebuild, or you can kind of configure which branch to use as the main branch. And then the tool chain, I mentioned it earlier. One of the main things that you can do with this is generate GraphQL queries, mutations, and all of that code for you on the client, so you don't have to write it yourself. And to do the code generation, Amplify CodeGen add, Amplify CodeGen generate. This will create all of the code for you based on the API that you currently have enabled in your app. And now we'll talk about AppSync. So AppSync is essentially the main thing that you would kind of think of it as is a managed GraphQL service. And we have multiple data sources that are first class, but really you can work with any data source that you like through a Lambda function with AppSync. A couple of the main features that people are using and we're seeing customers really have success with are the real-time and offline capabilities. Real-time is really just a feature of GraphQL, not AppSync in particular. But the offline capabilities are kind of a feature of AppSync because we built in some really sophisticated offline capabilities into our AppSync client, into our native iOS, native Android, and React Native and web. All of that is that's kind of part of the AppSync client. You can also use GraphQL really as a facade over a bunch of AWS services. So with the Lambda function, you can actually have your query go to a Lambda function, do whatever work you would like, and then have the return value be whatever the result of that operation is. We do conflict resolution in the cloud. So if you have multiple users kind of accessing the same piece of data, we handle all of the conflict detection for you in resolution. And then we also have first-class enterprise security features built in. So if you want to have all of your authentication kind of already configured for you, you can add Cognito or OpenID Connect as your identity provider, and everything is kind of already baked in for you. Now, GraphQL in general, the main things that you have as part of a GraphQL application are your schema, your data sources, and your resolvers. So you model your data with a schema. The schema consists of different nodes with relations to other nodes. So here we have a type of to-do, and then we have different fields within the type, and then we have a query. The query is what is the piece between the data source and the actual schema. And in between that even is the resolver, which we'll look at in just a moment. So you create your schema. You then have the client request whatever data that you like. Here we're just calling a get to-dos query. And then only the data that you would like to return gets returned. So even though we created this type of to-do with a description, we don't actually have to fetch that description. We can only fetch the ID if we'd like, or maybe the ID in the name. And one of the other reasons why people move to GraphQL and AppSync as well is kind of this idea of only fetching the data that you need. In a typical REST API, you're either doing a lot of overfetching or underfetching. And when you do underfetching, you end up making unnecessary HTTP requests. A lot of times when you overfetch, you're discarding data and you're bringing extra data across the user's network for no reason at all. This is a way to get around that, and it's pretty easy to kind of, it's just baked in. It's just how GraphQL works. There are three main GraphQL operations. So if you've ever worked with REST, you've probably been used to gets, posts, deletes, updates, those sort of things. There are two main operations, I would say, that you're going to be using for those types of mapping conceptually. That would be queries and mutations. So queries read data. Query is like a GET request. Mutations are similar to a put, update, or delete. And then there's this idea of subscriptions, which is what the real-time piece of this is. And subscriptions are built in to the GraphQL specifications, so they're first class. With the regular API, you probably have to write WebSockets or something to get this. And with AppSync, we have first-class support for now 5 data sources. This is outdated as of a few days ago when we added Aurora. So Amazon Elasticsearch, Amazon DynamoDB, Lambda, and also, just HTTP resolvers, which is here represented as a REST endpoint. So all these are first class, but if you have an additional data source that you'd like to connect to, you can hit a Lambda function, access your data source, and bring the data back that way. So you can really access microservices as well through the Lambda functions. And the main thing that when you're working with AppSync that you kind of need to understand is how to work with these request and response mapping templates. When you're getting into something more complex than a really basic application, you have to understand kind of how is the data going to be retrieved from your data source and how is it going to be returned back to the client. And you do this using your resolver, which consists of three main parts. You have the request mapping template, which is the request from the client to the actual data source, the response mapping template, and then you have the actual data source. So you can choose the data source that you'd like to be accessing, and then you define the request and the response to that data source. So what does a request mapping template look like, or a mapping template in general? This is a basic request mapping template, and this has three main parts: an operation. It also has a key, which identifies like what the actual key for the table is going to be. And then we have this attribute values property, and these are just all of the arguments that are passed into the mutation. And then for the response mapping template, you really have most of the time your response mapping templates are going to be pretty basic. This is just a very, very typical response mapping template. All we're doing is taking the response and turning it to JSON, and that's it. Most of the mapping templates that you kind of need in a real basic kind of, I would say in a real world application, we have those modeled for you. So we have a drop-down menu where you can just like pick the mapping template you'd like to start off with. A lot of times those will work out of the box. A lot of times you'll need to update them a little bit, but they kind of get you a lot of the way there, so you don't have to kind of learn from scratch how to write these. And one thing about these mapping templates, they're written in a language called velocity templating language. It's kind of its own syntax. So if you've ever worked with VTL, you probably know what it is. If not, we have a lot of resources on our website and our documentation about VTL. And also another thing that people ask is, how do you access things like the user's identity? What kind of information do you have available in these mapping templates? And like, what can you do with that data? Well, this is kind of a list of all of the things that are available. And in the mapping template, you have this variable called context. The context contains all of these properties here. So you have the arguments. The arguments are things like the arguments in a mutation to the actual template. You also have the identity, and the identity contains all of the information about the caller. So it might have their username, it might have their unique ID, it might have information about the service that they authenticated with. You also have the source, which is interesting because it's the resolution of the parent field. So if you have a resolver on a query, for example, then you can get the actual results of that query and then pass them to another resolver or another mapping template. Would be another resolver, yeah. So the source, I would say the arguments, the source, and the identity are going to be what you use in your request mapping template, and then in the response mapping template, you now have this additional arguments called the result, which is just the result of the query or the mutation. So getting familiar with those is pretty important in a real-world AppSync app. So what clients do we support? Well, we have the AppSync SDK for JavaScript, iOS, and Android, and we have the Amplify JS client. You can also use the Apollo client, but really the AppSync JS SDK is kind of like a fork of the Apollo client. But if you want to stick with Apollo, you can. You just have to manipulate the headers. So the main ones that we support are pretty much all of these except for Apollo, but you can also use Apollo, and we see people doing that for whatever reason. So. Two main ways, again, to create an AppSync service: through the console or through the CLI. We're going to be using the CLI. We just run Amplify add API, and then we run Amplify push. So what we're going to do now is take a look at kind of a application that contains a lot of the features that most applications do kind of contain. Things like user authorization, things like fine-grained access control, things like controlling user input, those sorts of things. And the app that we want to create has these features. It's going to be like a travel app. We want to have a list of cities that we'd like to visit, and we want to contain information about those cities, like locations. So we want to go to Paris, and we want to go to this restaurant. We want to keep all that information. We want to be able to view all of the cities that maybe have been created in general that other users have created. And then we also want to maybe only view our own cities. So we need some fine-grained access control there. We also want to view locations within the city. We also want to make sure that only authenticated users can even access the API to begin with. So we want to have authentication. Well, of course, I mentioned the fine-grained access control, which goes along, I guess, with only viewing your own cities. We also want to have a profile view so we can view information about the user. We want to see our name, our address. We want to be able to update that stuff. And then we want it to work offline. So we want to accomplish this using React Native and AWS AppSync, and AWS Amplify, I guess. So how would you do that? I'm going to walk through a few of these steps, and then I'm going to actually jump to a demo where we're going to do this in real life. You initialize a new React Native project, install the dependencies, and then you have to link a native dependency. That native dependency is Amazon Cognito Identity. You need that to perform some calculations around some authentication algorithm that you need as far as authentication is concerned. And once that's done, you kind of are ready to go. You can run React Native, run iOS, or run Android to kind of start your app. So the front end is done. What about the back end? First of all, you'd initialize a new Amplify project. You'd add API. And then when you run Amplify add API, you have then the opportunity to define your schema, or you can actually have the CLI recognize an existing schema you've already created. But we want to just go ahead and write a new schema. So what would the schema for something like this look? Well, it would really be pretty long because you would need to define your queries. You would need to define your mutations, maybe subscriptions if you want it to be real time. That wasn't one of the requirements, but you might want that. You'd also want to have inputs. You'd want to have inputs for the different mutations. Anyway, your schema would basically be pretty long. And you might want filtering for search and that type of stuff. But with Amplify, we actually have this library called the Amplify GraphQL Transform library. And it allows you to decorate your schema with different directives. So we have these two model directives, and the model directive tells Amplify, or tells actually AppSync, to go ahead and build out an entire schema based on this type. So not only does it create the type, but it also creates all of the different operations associated with the typical type. So you're going to have associated with the type, you're going to have queries, mutations, subscriptions, those sorts of things. You're going to want to list all of the cities. You're going to want to get a single city, that type of stuff. We also have a directive called connection. So if you need to specify relationships between different types, you can use this connection directive, and then you will have a way to query based on the ID of the parent type. So what we would basically do, create the API, use that schema. That schema, after we run Amplify push, goes to AppSync, creates the API, and creates this massive schema that we can now start using. Here are a couple of the different operations that will be created for us. We'll have create city, delete, create location, delete location, and then we'll have two queries. We want to list cities, and then we also want to list cities for the user. And we don't even need to pass in this argument. That was something that I removed that wasn't updated on my slide deck, actually, because what we're going to be doing is we're going to be accessing the caller in the context. So once the user's logged in, we can access the user context, that identity, and then we don't even need to, of course, pass in the ID, which is probably a bad thing to do anyway. It wouldn't be very secure. So once we have our schema created, like we want to test it out. To do so, we could run something like this. Create city has a name and a country. Then once we create a city, we get an ID back. We want to now reference the ID when we're creating a location because we want to associate this location with that city. So then we can use the city locations ID property, referencing the city ID, and then we can start adding locations within that city. If we want to list all the cities, we can run just this list cities queries, has the name, country, and the locations. And the locations has an items array containing the name and the description for the locations. Now we have the API created. What we want to now do is add authentication. So what we can do is we can run amplify add auth. And when we created the original API, we did not have any way to specify authentication because we didn't have authentication. But now that we have authentication, we need to reconfigure the API. So to do that, run amplify configure API. You'll have an option to choose the Cognito user pool that we just created. You'll have now two operations that need to happen. You need to create the authentication service, and you need to update the API service with that authentication information. So when you run amplify push, you'll get the different operations that are available to you, and then that's it. It'll be updated in your account, and you can start using it. So we talk about accessing the user's identity. So what's exactly in the identity? This is a very important thing because really most or all applications rely heavily on working with identity and authorization. So the context.identity has different properties depending on how they're authenticated. But these are the main things that you're going to see. The two things that you might use for unique identifiers are going to be the sub and the username. But you can also get information about the principal ARN, the caller, the Cognito identity ID, Cognito identity pool ID, and account ID. What we're going to be using is the sub. The sub is just a really unique ID. So if someone creates an account and then deletes it, it doesn't matter. The sub will never be duplicated. So what can we do now to actually work with this user's information? So we have the ID. What can we do now to associate data with this person? The way that we'll do that is we have this context.orgs.input object or map. We want to now add an additional property. So we want to add the user ID. So all we do is we call context.orgs.identity.put. We pass in the user ID as the key and the context.identity.sub as the value. Now every time we create an operation, the database stores information about the user. Now we have the user information in the database. We want to query for information based on that user. Since we have a user ID as a key on the table now, we can actually query based on the index of that user ID. So when we query for information for only a certain user, we can now just call a query based on the user ID. And the user ID is coming in through the context.identity.sub as well, so it's still secure. The information is only being accessed there. The identity, by the way, is kind of passed in through headers, and it's parsed by AppSync, so you don't have to worry about any of that. It's kind of done for you. And then we see that we have the index as the user ID index. So let's look at how to do this on the React Native client. Let me go ahead and switch over. Oops, I think my computer turned off. So I'm going to be doing a little bit of live coding, but not a lot. It's going to be fun. So we have our React Native app. This is just me running React Native init. What we want to do is we want to add a lot of that functionality that we just looked at as fast as possible because we only have, 20 minutes? So how can we build all of that out that quickly? Well, I'm going to be doing it in 3 steps. When you run these Amplify commands and you're building resources in the cloud, sometimes they take a minute or 2. So I'm going to be kind of going from a base project, adding things, and then I'm going to be going to the project that I currently have that has some of the configuration already there. So in the React Native project, we see here we have really basic project. If you ever seen a React Native project, you know that you just have your app.js and your index.js. So we want to initialize a new Amplify project. So to do that, we'll run amplify init. Let me bump up my text size a little bit. It's kind of small, isn't it? So amplify init. We are asked for a name for the project. I'll call this RN, or reinvent. Now we're asked for a name for the environment. This is something new with the updated CLI. We're just going to call this dev. The text editor, this is being asked because down the road, the CLI will automatically open some files for us, and if it knows which text editor you're using, it can go ahead and open in the proper text editor. The type of app, JavaScript, it's going to auto-detect everything from here. So it's going to auto-detect JavaScript. It's going to auto-detect the framework, which is React Native. It's going to ask for a couple of other things. I'm just going to take the default for these source directory, distribution, and build command and start commands. Since this is an actual mobile application, we don't really need the build or the distribution directory anyway. Now it's going to ask us for the AWS profile. I'll go ahead and use an AWS profile. And I have a few on my machine. I'm just going to choose this EU Central. So once you have done that, it's going to go ahead and go through some steps. Or it's just going to take some time. And then you're going to have this new Amplify folder in your project. So after you've run Amplify init, you'll then have this Amplify folder, and you can run Amplify status to see what's going on in your project. So this gives me my current environment. It also gives me a list of all of the different services that are enabled. Right now, we don't have any services enabled. So what we want to do is we want to go ahead and add API. We also want to add authentication. So I'll run Amplify add API. For the type, I'm going to choose GraphQL. For the API name, I'll call this rn reinvent. For the authorization type, I'm going to choose API key because I don't have any other authorization type created yet. Do I have a schema? Nope. Do I want a guided schema creation? Yes. This is going to give us the opportunity to kind of edit a base schema that's going to be created for us. And it's going to give us two options between the schemas that we want to start with. Either a single object with fields, which is basically just a type with 2 or 3 fields, or an example of one-to-many relationships. It doesn't really matter which one we choose because we're going to be overriding it anyway. I guess I'll choose one-to-many relationship. And then it's going to say, do I want to edit the schema? I'm going to go ahead and choose yes. So this is going to go ahead and open up the schema in our editor. The schema that we're going to be working with is this schema right here. No, actually, this is the one they're giving us, so we don't want that. This is the schema we want to work with. We have a type city that has a name, a country, and an array of locations that are associated with it using this @connection decorator or directive. And then we have this location type that has a name, a description, and an address, pretty basic stuff. So now that we have this schema created, we can save it and jump back to the command line and press enter. This is going to go ahead and generate the configuration for our API. Now that we have our API configured, we can run Amplify status again. And we should see that we have an Amplify project category there, but the operation is create because we haven't actually created it yet. And we don't want to quite create it yet. We now need to add authentication. So I'm going to run Amplify add auth. Do I want to use the default configuration, or do I want to write my own configuration? The main difference is the default configuration is going to give you MFA on sign up and just username and password on sign in. Whereas if you wanted something different than that, you could go to the second option. This demo, I'm just going to choose yes, so we can go with the default config. Okay, now we have both created, but now we want to associate this new service, this auth service with our API. So we want to run Amplify configure API. Now we can go ahead and choose the API we want to configure, and we want to update this authorization type to be Cognito user pool instead. And we see a little note here that's pretty important. It's basically saying we're going to use a Cognito user pool that's configured as part of this project. So it's going to go ahead and recognize that we have this Cognito user pool. It's going to use that, and that way we don't have to kind of do anything. It's kind of already there for us. So now we can run Amplify push. We have now 2 operations that are going to happen. We're going to create an API. We're also going to create an auth service. So go ahead and choose yes. That's going to go ahead and start building. Oh, this is pretty cool. This is the code gen stuff I talked about earlier. It's going to ask us, do we want to automatically generate code for our schema? Based on our schema. We're going to go ahead and choose yes. It's going to give us a couple of options. We can either choose JavaScript, TypeScript, or Flow. I'll choose JavaScript. It's going to ask us the file pattern for the folder where it's going to put all of these operations. So we're going to have like a mutations folder, a queries folder, and a subscriptions folder, and a schema. And we can say we want it to be in GraphQL / whatever. I'm just going to choose the default. And now it's asking us, do we want to generate all of the different operations? Do we want queries, mutations, and subscriptions? Sure, why not? And now it's off to the races. It's actually going to generate the code locally. It's also going to create the service in our account. So what happens after that's done? We're now at this point where we have our Amplify folder. We now have an AWS-exports.js file as well. This file is created after you create your first service. This has all the information about the different services that are part of your project. So let's go ahead and take a look at this file real quick. Or we'll take a look at our project. So we have this AWS-exports, just has different things about our GraphQL endpoint, our authentication service, and that type of stuff. So now that our app is created and we have our services initialized, we're still left with this blank React Native app. How can we start adding stuff? The first thing we want to do is we want to authenticate this. We don't want anyone to be able to access this API unless they're logged in. So let's add the authentication using the with authenticator higher order component. So I'm going to delete some stuff that we're not going to be using here. Go ahead and refresh. Okay, so we have our app is still running, and we know that this is the right code we're working with. So we're going to import something called the with authenticator higher order component. This is being imported from AWS Amplify React Native. This is a platform-specific component. Now, instead of the default export being the class, we want to just have the class definition there. We want to create a new default export. The new default export is the with authenticator higher order component, and we're passing now the actual app component that we created. And then we have a second argument that we can configure this higher order component, because it gives us a lot of stuff out of the box that we might not want. Styling, for example, theming and all that stuff. The argument we're passing in is include greetings. This just adds like a log out button, a sign out button. So I can save that and refresh. Excuse me. Okay, cool. So that actually works. So now we have our app is protected by this sign-in flow. So you can sign up, you can confirm a code you already got, you can sign in, or you can get a password reset sent to you. I haven't signed up yet, so let me go ahead and create a new user. One other thing I haven't done yet. We talked about how you have to configure your Amplify app before it can actually use Amplify. To do that, we're going to open index.js, and we're going to call amplify.configure. So we import Amplify from AWS Amplify, we import config from AWS exports, and we call amplify.configure, passing in the config. This only needs to be done once at the root level. So we've done it. We can now close index.js and try this one more time. So sign up. All right, so now we're at the confirm screen. I need to get my MFA code, so I'll go ahead and open my email. Whoops, okay, there it goes. So, confirmation code. Okay, so we're signed up. Let's go to our user pool and take a look at this new user that we have. Well, actually, this is from before. I never deleted my other user, I don't think. Well, anyway, we have the user there. Let me go ahead and sign up another user so we can actually see this in action. Well, let me just delete this user, actually. All right, so now we have another code. We'll go ahead and use that here. I think this should be Dabbit 4. All right, so now we should see Dabbit 4. Okay, cool. So we see that this is actually working. We'll go ahead and log in, Dabbit 4. I'm getting an error. Let's see here. Oh, no, I'm not. Okay, cool. So let us log in. So now we're logged in. If we refresh, the user is persisted in storage, so we now see like a loading indicator while we check for the user. When they close the app and they open it, they stay logged in. So we're done with the authentication. Now we want to add the GraphQL. We want to start working with our GraphQL API. First thing we'll do in app.js, we want to import the necessary components that we're going to need. What we're going to need is we're going to need the APIs from Amplify that are going to be interacting with the API. So those are API. API has get, put, delete, those type of operations associated with it. But it also has a GraphQL, so you can call api.graphql. We have GraphQL operation, which is a helper that basically takes GraphQL operations that are query strings and turns them into GraphQL AST. We also import our two operations, list cities and create city. And then we import a few different UI components from React Native elements. What we want to do now is we want to have a form where someone can create a city, and then we want to be able to list the cities that are created in our API. So to do that, we want to create some initial state. The state we want to keep up with is an array of cities. We want to keep up with all the different cities that are coming back from our API. We also want to keep up with the name and the country of new cities that are being created in our form. After we've created the state, we now want to also create a few methods that are going to handle user input. We also want to have a method that's going to query for the data when the app loads. So when the app loads, we want to go to the API, get the data, and update the state. So if you look at component.didMount, you'll see we have this function that calls api.graphql, passing in the GraphQL operation and the list cities query. We take the variable items by destructuring that return value, and we call setState, passing in the items to the cities variable, just updating this cities array. So the app loads, we fetch the cities, we update the data. Next, we have an onChange handler. This just takes the user input and stores it in the state. We call setState, passing in the key and the value. The key would be something like country or city, and the value would be the value that the user is actually typing. And then we have a method called createCity. CreateCity first creates a new variable called city, and here we store the name and the country. We then do an optimistic response by calling this.setState, passing in an updated array. We take the old array, pass in the new city, and then update the state. So when the user creates, we update the UI with the new city. And then we call the api.graphql, passing in the createCity GraphQL operation, and taking the city variable we created as the argument for the input. Finally, we need to render all of this to our UI. So the way that we'll do that is we'll have a couple of inputs. We have these two form inputs, takes in the city name and the country name. We have a button that calls the createCity method we just created. And then we just simply map over all of the cities in the array. So whatever cities are there, we just call the this.state.cities.map, and we're good to go. So let's refresh. One other thing I think I forgot to do, let me go ahead and update this styling a little bit to make sure that when we render a few items, they're not mushed together. So we have our input. So let's go ahead and create a new city. We created 2 cities. Let's go ahead and refresh. See if the data gets pulled back from our API properly. We see the data is there. Let's go ahead and make sure, though. In AppSync, we're going to go to the reinvent GQL dev, which is the API that I'm connected to here. And we can click on data sources in AppSync and see all the data sources associated with this. We want to look at the city table because we want to see the cities, of course, that we're looking at here. If we go to the items, we can now see the 2 cities we just created. So we have Paris and Las Vegas. That's cool. What now we want to do, though, is we talked about we need to have some type of fine-grained access to this data. We want to also be able to query data based on the user. Right now, in our DynamoDB table, we have some information stored, but we don't have anything about the user. We need to know if the user created, or which user created each item. So the way that we'll do that is we'll go to the AppSync console, and we'll go to our schema. And on the right-hand side, we have access to our resolvers. And we're going to look for our mutations, because the first thing we need to do is associate a mutation with the caller. So what we're going to do is we're going to call context.args.input.put. We're going to basically take the input object and add the user ID there. And the way I can do that is just by copying an existing field, and I'm going to pass in user ID, and the user ID is going to be the context.identity.sub. Okay? So I can save that resolver, go back to my app. I should be able to go ahead and create another city here. Update our DynamoDB table. Now we should have a user ID associated with that new piece of data. Okay, so we have the user ID there. The last piece is to add functionality to query based on that user. So how can we do that? Well, we can have a query cities by user query. And the way that we can see how that works would be to go back to the schema, find an existing query that does the listing of cities. So that would be something like this, list cities. And we now are doing a scan. When we call list cities, we're scanning and we're taking everything out of the table, returning it, and that is the data that we're working with. Instead, I'm going to comment this out. Whoops, well, it doesn't matter. I'll delete that. We want to update this to be a query on the index. So we're changing that to be a query operation as opposed to a scan. We're specifying the index that we want to work with, which is the user ID index. And then we're passing in the expression, and the user ID is going to be the expression, and the value is coming again from the context.identity. We're reading this based on the currently logged in user. So if I save this resolver and I query again, I should only now get the Madison location because I'm only querying for the data for the user that's currently logged in. There we go. So now we're doing some type of fine-grained access control. This resolver went from querying the entire table to only querying based on the user that's currently logged in. So that's kind of it. So we went over some intro to React Native stuff, but we tried to kind of dive in to a lot of different topics. We give a quick overview, but the main takeaways from this, I would say, would be to kind of work with the context when you're working with AppSync. Try to understand how to work with the context because you're going to be using it a lot. It's very powerful. It's a good way to kind of like get a head start, I guess, when you're working with AppSync, knowing that you should kind of focus on that. Focus on working with the request and response mapping templates. If you're going to be building a production app, you're going to be updating and changing those a little bit. And also look at the Amplify CLI and look at working with the multi-env. It allows you to quickly experiment and create new APIs, tear down all the resources associated with them, so you're able to kind of just play around and learn new stuff. So thank you for coming. That wraps this up.